Hey everybody, this is Larry. This is the 2nd of April. Hit the like button, hit the subscribe and join my Discord. We're going to be doing this all April probably. And when we have a long streak, so we'll see how that goes. Today's farm is ones and zeros. Hit the like button, hit the subscribe and join my Discord. Let me know what you think about today's farm. If I'm going a little bit fast, it's because, I don't know, any Dota fans out there? The Singapore Major is happening right now, and there's an exciting game going on. But anyway, we'll see how fast this goes. Today's farm is ones and zeros. You're given an array of binary strings and two integers m and n. At most, return the largest subset of strings such that there are at most m n's and n ones in a subset. Okay. Let's look at the inputs, I think. Okay. Okay. So yeah, so this is yeah, I mean, this is dynamic programming. Yeah. That's why the first thing I looked at was the number of m's and n's, because this is dynamic programming. Basically, this is almost like coin change or something like that in 2 dimensions. And you're trying to get, for each string that you can use, you get a cost of 1 or a change of 1 or whatever you want to call it. And yeah, and let's do that. I'm gonna do it top down, though bottoms up should be pretty straightforward as well. Well, for some definition of straightforward. If it's not straightforward, definitely practice. I always recommend practice. And not just practice solving it, but practice up solving it to bottoms up. It'll come in handy for certain problems. And once you do that, do the space optimization to reduce space if you see those opportunities. Again, I usually have a link for dynamic programming videos below on the comments or whatever on the dynamic programming progression that I always can do that explanation. So I'll go over it later, but for now we'll focus on this part. So yeah, so now let's just get, let's just have a get max, say. We have let me do some math actually. Can we do it tops down? 600 times 100 times 100 is 6 million. So I guess it's a little bit slow. I don't think that we can do it top down, because what I was going to think about is that the states are index m and n, or m left and left, something like that, and then you go through the index one at a time. But of course this is going to take, without even completing this. And this is actually a very straightforward dynamic programming that we can write very quickly, I guess. But analyzing it before I write it, and this is what I would do during the contest or interview, or maybe just talking about it during the interview. Index can go from 0 to n. Well, 0 to n, where we use n is equal to the length of strings. Let's rename this to zeros and ones, because that's more accurate. Yeah, so index would go from 0 to n, zeros would go from 0 to, zeros, and ones would go from 0 to ones, and as a result, you get n times zeros times ones, which in this case could be 600 times 100 times 100, which is about 6 million, which maybe is fast enough in some languages and stuff like that, but in Python, especially on Leetcode, is a little bit sketch. So yeah, we're not going to do that. But the idea here is that, okay, for each string, we see if we can use it, and then we just have 2 cases, right? We return the best of, or the max, if you will, of either best of index plus 1, zeros minus using this. So like, do some math on, I mean, I'm hand wavy a little bit. We'll actually implement it in a second, but basically like zeros of index or something like that, and then ones minus ones of index or something like that, right? And then also just not using it, so zeros, ones, and this is this plus 1, I guess. So this would be the dynamic programming. Of course, I'm not doing base cases and all that stuff, but that's basically the idea, and that should be good. But now, of course, as we said, this is too much. In terms of time, it's okay. You can don't think you can do that much better, but in terms of space, 6 million elements, because I think also it's not, yeah, because it does take time to access the memory. So maybe you could do it tops down if you're really careful. But at a certain time, it also takes time to allocate memory and stuff like that, which is why I'm a little bit skeptical. Though if you solve the top down, let me know in the comments, and let me know. Yeah, I'm actually curious. But at least for me, I'll be like 6 minutes a little bit sketch. So yeah. So okay. So that's for me. Take a snapshot of this. I'm going to erase this for now. Yeah, and then now let's pre-compute the number of zeros and ones in a string. So let's just do z is equal to 0 times n. O is equal to 0 times n, and then for for each string in s 0. Oh, I guess we have to get the index. So let's add enumerate. So index is equal to s dot count of 0, and oops. Once of index is equal to length of s minus 0 of index. I mean, and you could just do count 1. It probably doesn't matter that much. Okay, and then now the dynamic programming part. So we want to I'm thinking about how to explain it, because I think right now what I want to do is do the space optimization thing ahead of time. But the key thing to notice about this part is that you need to do things in one direction in the right for loops. So that's why I'm a little bit, yeah, I don't know. So we'll see. So this is z times zeros plus 1, or is it now? Doesn't really matter, I guess. But I'll put, so something like this, right? So now we have a DP array, best results given, okay, so DP of ij is equal to best result given I zeros and j ones, and then now we write something like, yeah, and then we have to go for each string. So yeah, for each index in range of n, so each string at a time. We want to, so the thing is that because we're reusing the array, and actually maybe I'm doing this in a crappy way, because I think you can actually, okay, actually let me rewrite this a little bit, because so a little bit of a spoiler alert, and if you're upsolving, you can actually do this in 1 2-dimensional array, but for learning purposes, I'm going to do it in a 3-dimensional array, just for learning purposes. Again, this is a really it comes up from time to time, but it doesn't come up that often. So it's a really like next level upsolving. It's not even in my dynamic programming video, because it comes up only like from time to time. The different for loop ordering, so that you can do this in 1 2-dimensional array. Try to upsolve. I mean, if you're comfortable about it, try upsolving that at home. So yeah, but for me, I'm just going to add I'm going to add it's such a mess to it's a really annoying to do three-dimensional arrays in general, because if you do it the wrong way, it has the same reference. That's why you don't do it that way. Is this right? I'm not even confident, even though I have a lot of Python experience. Okay, it doesn't give me an error, so that's good. But yeah, is 0 the best answer? No, maybe not. I think we would actually use another flag, but I'm going to use 0, 1 for now, and then set the 0 to true. Or to 1, whoops. But yeah, again, check out my upsolving video on dynamic programming if you have any questions, or ask questions of me and my Discord and all that, you know, stuff. But yeah, so now we go over index one at a time. And then the key thing to note is that, and this is what I don't know if I do talk about this specifically in my dynamic space optimization problem, but the idea is that, actually, I don't want to do it this way. My bad. Oh no, I want to do it this way so that I don't keep on allocating memory. That's why I did it this way. Okay, but yeah, now we go through zeros and ones all together. C current maybe in ranges of zeros plus 1, for one's current in 1 plus 1. I guess we could start at 1 because there's no point. Oh no, I guess we actually should start at 0 because it might. But yeah, and then the recurrence is the same as before. When we're here, I think I'm doing this a little bit funky way, but yeah, you can do something like this where let's just do a push. Let's just do a push. Okay, yeah, let's do a DP. Okay, so that means that, you know, we start at this minus z of index, and this is minus 1 of index, and then yeah, so then this is equal to dp of index mod 2. I'm skipping some step with the optimization, so forgive me a second, but let me think about this. You go this plus 1 if dp see, 0, 0, something like that. Okay. The reason why this is a little bit awkward is actually here, there. I think maybe that's better. Is it? But yeah, so you have this plus z of index. That's basically using this is a hard problem for day 2. It's either that or I'm doing this really funky way, to be honest, and there's a greedy solution or something like that. But yeah, basically this is saying that if this is possible, meaning that it's 0 or greater, we add the next index to the thing. Or we add, you know, we try to add this to we try to add 1 to it so that, you know, that we use this, right? Else, yeah, I think that should be okay. And then now we want to clear out the index mod 2, so we do something like this, I guess. And actually, just as a small optimization, let's just do current is equal to index mod 2. Next index. Next is always a little bit awkward because it's a keyword, but next is equal to index plus 1 mod 2. You may think that you know, so then this is actually easier to read, but also it saves a lot of operations. And I think so that's pretty much it. So then also we want to make this possible. And also I messed up here. because we should take the max, right? It's not a given that we would do this. Okay, and then now we clear it out, and at the very end we should be able to get the max. So by going through why did I have something funky? Probably forget something somewhere. Oh yeah, okay. But yeah, but now we're going through the last array, of course, to see how many what's the most thing that we can use. So max is equal to max of dp of n mod 2. Yeah, n mod 2, and that means that no, it's n plus 1 mod 2, I think. No, is it? No, yeah, it should be n mod 2. Whoops. And then that's it. Oops. Hopefully. Because I feel like it wasn't that long ago. I was like, oh yeah, this is easy. And then it was not. Ooh, on-time error. I think also normally I would do this another way where I don't use this thing with the current in the previous. But that's what I was worried about. I have to figure out how to do 3D in a good way. I could do it in the for loops as well, I guess. But oh, I did it. Oh no, I did it the dimensions in the wrong way. It's so easy to get wrong. Because what I actually want is something like this. Because you have to do it out. It's inner, outwards, whatever. Okay, let's actually do this the dumb way, where you know for okay, so here we want an array, so let's just do current is equal to well, it's just this is -1 times 1 plus 1. Okay, so this one I don't maybe need this for loop, and then here yeah, so here is equal to so then here we can just do current dot append this, so yeah, and then dp dot append current, so maybe that's a little bit more readable. Still yucky as hell. Okay, so this is not right at all. Why is this giving me 4? I mean, I know why it's giving me 4, but why am I wrong? So wrong. So wrong. 0 is not an expected answer though. Like I expected maybe if I'm wrong, I get it wrong in another way. But that's awkward. Current. No, that should be okay. The last one should be n-1, so I think one awkwardness is that you can always this should take that into account. The 0 was what I was thinking about, but maybe not. Maybe this thing. I think this thing actually messed me up. Because this thing doesn't activate for certain things, so we just have to add this here. C plus C of index is zeros, and OC plus O dot. And if you're wondering if how I could debug so fast, it's just that you make enough mistakes the same way, it comes up. So that was definitely probably an issue. But now I'm still, Let's print it out real quick. I mean, 0 looks good, and there's a... Where am I printing? Let's print just a subset. They're not wrong. There's a 2 here, but then it disappears. Also, the 0 disappears. Why is that? Oh, I am just being dumb. I mean, I had the right fix, but I put in the wrong place because I was okay. Because same reason as we just talked about, this should be here for this part, so that doesn't affect this part. But I don't know. Sometimes when I get busy talking, I get a little bit confused. So there you go. Am I confident about this? I guess so. So let's give it a submit. Maybe I have a wrong answer. I don't know. We'll see. As long as it doesn't time out. If it times out, I'll be sad. Okay, cool. I am... Don't worry, I'll go over it in a second. I'm just trying to think for a second whether there is a better solution. Because it doesn't... this seems pretty hard for a day 2, to be honest. That's why I mean, it's not hard. It's just a lot of things that you need to know. So if you don't know how to do this, it's fine. Because I think you just need to build up that knowledge. And then you have to figure out optimizations. And again, I'll have the dynamic programming progression video in the link in somewhere in the YouTube comments or whatever. Check that out. It goes over some of the thought process here, so I don't want to spend that much time on it. And I'll but it's still not straightforward. So don't feel that bad. And yeah, let me know what you think. Cool. And before that though, before I call it a night, I do want to see. I mean, the solution thing doesn't. Nope. Let's see what the comments are saying, because I am curious, like whether, I mean, it just feels a little bit hard on the meta, but it, like, it's not a problem for me per se, as you saw, but and this is a medium problem. Like maybe there's a easier solution and I just did it a really hard way, for which then my apologies. No, I guess not. Okay. Yeah, I mean, I was thinking about coin change, but I guess it's more knapsack. They're not wrong. Okay. Yeah, I mean, I to be honest, I just thought there may be some. Yeah, I mean, this is, and this is actually the thing that I was talking about with respect to changing the order of the for loop to make it a little bit quicker. But we're not gonna go with that. That if you're having trouble with it, that's okay. Yeah, let me bring it back up. Let me talk about complexity for a second. I think I kind of skipped over that one. Why is it not bringing back me? Sorry, friends. Hang on. Oh, yeah, your luxury at home. You can fast forward a little bit. Why is my computer so... okay, there we go. So yeah, so in terms of time, we have for loops, so you can kind of see it really quickly. This is going to be n times, the input zeros times ones, as we talked about earlier. And in terms of space, we did do this compression so that we got it down to, here, which is of course 2 times zeros times ones, which is you go to, whatever it is, right? So this is a little bit faster, or a little bit, I mean, it takes less space, but which also makes it faster because of memory access takes, at a certain point, does take time, because there's linear space usage here, but otherwise everything is, that's pretty much it. That's the space and that's the time. I think the tricky part about dynamic programming, obviously, is just coming up with the solution. After that, like the time complexity is not, is not that hidden. So yeah, I think that's all I have. This I guess knapsack is pretty standard, but this is a little bit, but it needed some optimization, right? Because I think the naive knapsack, like the one that I was showcasing a little bit earlier with top down, that wouldn't work. So yeah, let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. This is day 2 of April. I hope y'all, join me for the rest of the month. We'll be buddies together. Join me on Discord if you have additional question. And yeah, take care of yourself, take care of others if you have a good chance. I got my shot today, so I'm really excited. Yeah. Hope y'all have a great rest of the weekend, rest of the month, and I'll see you soon. To good mental health. Bye bye.